Then classification of polymeric materials on the basis of application. So there are different applications like specialty polymer, commodity polymer, engineering polymers. What are the specialty polymers we are going to discuss in a detail. Okay, so specialty polymers the polymers which are having designed for specific properties or characteristics are called as specialty polymers. Like some polymers are designed for their particular shape, some are designed for chemical properties, some are designed for mechanical strengths or mechanical properties. So these are specialty polymers, and these are ranged from monofunctional to polyfunctional polymers. Some polymers are having single use, or some polymers are having multiple use or multiple functions. They can be cheap as commodity, means they can be cheap as a commodity polymers, but can be extremely expensive depending on their area of application. See, commodity polymers means these commodity polymers are produced in large quantity or in bulk quantity, so they are cheaper one. And these specialty polymers are specially designed for particular purposes or particular characteristics, so there can be having very high cost of these specialty polymers. So classification of specialty polymers: conducting polymers, electroluminescent polymers, liquid crystal polymer, biodegradable polymer, biomedical polymer, and polymeric composites. These are different classification of specialty polymer depending on their properties or depending on their end use. So we will discuss conducting polymer in detail. Definition: conductive polymers are organic polymers that conduct electricity. So the electric conductivity can be imparted by using two function mechanisms. So there are two types of conduction polymers: extrinsic conducting polymers, and another is intrinsic conducting polymer. Extrinsic conducting polymers are formed by addition of external ingredients or fillers. What are these fillers? It can be metal fiber, it can be metal oxide, or it can be carbon black, etc. Materials can be mixed with the polymers to form to give this polymers a conducting property. So the external ingredients or fillers are used. That is why it is called as extrinsic conducting polymer. Intrinsic conducting polymers are the conducting polymers which have their conducting property because of organic polymers themselves. मीन्स इसमें जो ऑर्गेनिक पॉलीमर्स है उसकी वजह से ही उसका कंडक्टिंग प्रॉपर्टी हम एनहांस कर रहे हैं. सो दैट इज इंट्रिंसिक कंडक्टिंग पॉलीमर्स. These organic polymers are made of conductive by doping with suitable agents. Okay, means conducting polymers can either have its conducting property. If the conducting property is means conductivity is very less, we can add some doping agents to enhance this conducting property. So the poly, for example, polyacetylene is conductive due to conjugated double bonds that allows pi electron to delocalize. Okay, so polyacetylene is having double bond, that is pi bond. So these delocalized pi electron can have conducting properties, but if that conducting property have to be tailored, so we can add some doping agents for the enhancement of this property. So here are some examples of conducting polymers. Then doping of the polymers. The polymers can be doped using different mechanisms like oxidative doping and reductive doping. Oxidative doping. In oxidative doping, polymer is treated with oxidizing agent like I2, aluminum chloride, HClO4, that is perchloric acid. So the different oxidizing agent can be used. Oxidizing agent takes away electron from the pi backbone of the chain, creating the positive holes. Okay, and these polymers become p-type conductor as the conducting as it conducts by the movement of positive holes. Okay, positive holes की वजह से इसका conductivity है, so that is why it is called as p-type doping. And what is n-type doping or reductive doping? Polymer is treated with reducing reagents like sodium or lithium naphthalides, etc. So reducing agent supplies electron to the pi backbone. So pi bond is there. So for that pi backbone, electrons are supplied. to the chain, and because of that extra negative charge will be created on this chain. Okay, that extra charge will be because of lone pair of electron. So this polymer become n type of a conductor because a negative hole is created. For example, oxidative doping, that is p doping. In this for example, this is treated with iodine, which is dissolved in carbon tetrachloride solvent. When that when the polymer is reacted with or doped with iodine, so the iodine is oxidizing agent, so it will oxidize the polymer chain. Okay, so one electron will be taken away by this iodine, right? One electron will be minused from the polymeric chain, so there will be only one electron, so one radical will be formed. Okay, so as one of the electron is taken away, so there is a formation of positive hole at one of the carbon, and one of the carbon will be having one electron, that is in radical form. Again that doping agent will be attacking on another side, so to create one of the radical and one of the positive hole. So these two radicals combine together to form a double bond, and rearrangement will be there or recombination will be there. So this is how these radicals will be getting recombined and holes are getting created. So positive holes are created here, so these positive holes are uh, responsible for the conducting property of these polymers. Another type of doping is reductive doping, that is n type of doping. What is n type of doping? Negative hole type of doping. For this, what reagent is used? Sodium naphthalide. It is dissolved in THF. Okay, so sodium naphthalide is treated with this polymer, and sodium naphthalide is a reducing agent. Okay, it will supply electrons to the polymers. So because of the extra electron, there is a formation of lone pair at one of the carbon, and one of the electron from the double bond will be forming radical at another carbon, right? So negative hole is created at one of the carbon because of the lone pair. Again another sodium naphthalide will be attacking on another side of this polymer. Okay, again creating negative hole here and one of the free radical over here. These two free radical recombine to form a double bond. Okay, so the double bonds in the last figure you can see, in last step you can see the recombination of these electrons, free radical electrons getting takes place, and because of recombination two double bonds can be seen here. So now ultimately these negative holes are created, and these negative holes can be created a number of times, and these negative holes are responsible for the conducting property of these polymers.